Morning all. Now this is part 3 to my tutorial series on driving the Nokia 5110 liquid crystal display, and at the end of part 2 I wrote the words "the end" on the display, and they are on there, but they're a bit tricky to see because this, oh they are, you can see them there. This is a different display. The previous one had blue LEDs, this one has white obviously. And it obviously has also a different contrast requirement because the pixels that are not meant to be on are mostly on, and we can't see the text very well. So the first thing I need to do is change the contrast. And in fact, I'm not going to change contrast, I'm going to change the bias. You can experiment with different values for both these items to get the best display. So here's the code from part 2 of the video, and you can see that contrast is hexadecimal BF. And the bias mode is hexadecimal 14. Now in the new version of the program that I'm working on, I've actually still got BF for contrast. I've put it in lowercase, but that doesn't really matter. The bias I've taken down to 10, and that works on this display. So I'm just going to put that into the old file just to get this display working as a starting point. And that's brought the display back to visibility. Now in the first part of this tutorial, I was fairly adamant that these displays work perfectly well on 5 volts, and there's none of the vagueness that the seller of my original LCD was talking about, but I'm not so sure now because I'm getting little bits of swirl, just movement on the switched off pixels. It's about as good as I can get it, and that's why I've changed the bias setting rather than contrast, because I found it just gave me a better result. So it is possible that at the higher voltage these displays are just slightly more problematic, but if you fiddle with those values you can get a reasonably good result. So the purpose of this part 3 to the tutorial is to get live updating numerical data on the display, and what I'm going to do is I'm going to read that data in from a potentiometer which is connected to an analog port, do a simple conversion and get the voltage on this potentiometer, which will be between 0 and 5 volts, displayed live on the display in numbers. So let's take this in easy steps. The first thing I'm going to do is change the wording "the end" to voltage and move it onto the left-hand edge of the display. So in the previous version we started writing the end at column 20. In this version I'm now at column 0. So let's compile and load that one in right now. And the result of that is simply this. We have the word voltage and a colon on the left hand side of the display, and then I want to put the actual voltage to the right of that, but live, constantly updating, so that as I turn that potentiometer the voltage value on the screen will change in real time. And that means adding a few lines of code into the loop function. So here's my new program. I've got just 3 lines of code added into the loop function and a variable declaration just above that, and so I'll go through those lines of code and explain what they do. But before I do that, let's just upload this, compile and upload this, send it to the display and check that it's working. Okay, well I've put the numerical value on the wrong line. That should be 2 lines further down, but let's just check that turning the potentiometer adjusts that value, and it does. And it runs from 5 volts for the maximum value all the way down to 0 volts as a minimum. So that works. I'll just move that onto the correct line, and then we'll go through and explain how that those 3 lines of code work. So here's the error on the LCDXY. 50 is correct, but line 0 needs to be line 2, and that should do the trick. I'll just compile that. And so here's the result. We have voltage and then a number which has a single digit followed by a decimal point followed by 2 decimal places. So that's fine. Let's look at the code. So on the first line I'm declaring a variable called voltage. It's a float variable, which means its floating point can have numbers after the decimal point. making that equal to an analog read. Now the potentiometer just happens to be connected to analog pin A4, so that's why I'm doing an analog read on A4. I'm then multiplying by 5.0. Now if you multiply by just 5, it converts the output to an integer, and we don't want that, we want floating point, so it has to be 5.0. Divide by 1024. This calculation here changes the scale of the output from the analog to digital converter, which is 0 to 1023, to a range 0 to 5, and that's volts. That's why we get the potentiometer running from 0 to 5.0. Okay, second line, LCDXY. This was the function that we wrote in part 2 to position text on the display. I'm now positioning it at position 50, so quite some way to the right of where we wrote voltage. That was positioned at position or vertical column 0, row 2. This is vertical column 50, also row 2. And then we use the LCD write string, which is able to write strings to the display. And this is the new bit. This function, DStringF. This is a function from the stdlib, STDLIB, which is part of Arduino, which can do conversions from double variable or double precision float variables to a string. You have to specify certain things. You have to put in the variable, the source variable, which here is voltage. You have to put in how many characters you want in the final string. So that includes the number before the decimal point. It includes the decimal point itself and the 2 digits after the decimal point. You specify with this 2 how many digits you want after the decimal point. And then here is the string that the output from DStringF is dropped into, so that we can then write it to the display. So let's just have a quick look at this DStringF function. I've simply typed DStringF into Google, and the first result is this, stdlib.h, general utilities. The DStringF function converts the double value passed in val into an ASCII representation that will be stored under S. Now this is in the AVR lib C user manual, so let's just click through and have a look at that. So here are the conversion functions for double arguments. We've got DStringE and DStringF. If we look at the documentation further down, DStringE is with an exponent, so times 10 to the whatever. DStringF just gives you a floating point numerical value output. So here's DStringF. You pass in 4 parameters, a double of the value. Now you can also pass in a float, because that's what I'm doing. A signed character for the width, that's the number of characters in the overall output. An unsigned character for the precision, that's the number of digits after the decimal place. And then a character array. And here are those 4 parameters that I'm passing in on my use of DStringF. Voltage, 5 for the overall width, 2 for the precision, and my character array is string. So what I'll do is I'll put this Arduino code in as a comment to this video, and you'll also need font.h, which is this file, and it simply sits alongside the Eno file in the same folder, in the same directory. I'll put that in as a second comment, and then by combining these 2 files, you'll have all the code you need to drive the Nokia 5110 and write text and live numerical data to the display. So that's it. With those 3 lines of code in the loop function, we now have live updating numerical data on the display, which you can take from any sensor. I'm just happening to use a pot because it's nice and easy. Get live numerical data on your display for whatever project you're working on.